Why would an airline choose DOT to fly a longer route on purpose? Look at a flight from Asia DOT to North America on a map. The route often curves far north, sometimes close to the Arctic. At first glance, it looks like a huge mistake. Why would pilots avoid a straight line and take a longer path instead? The surprising answer is that DOT the airplane is not the problem. The thing misleading you, DOT, is the map itself. The world map you've seen your entire life, DOT, is actually a distorted view because of Earth is a sphere, but maps are flat. And when you turn a round planet into a flat picture, something has to change. Distances, shapes, DOT, and directions can all become distorted. A route that looks curved, DOT, on a map may actually be perfectly straight when viewed on the surface of the planet. Imagine peeling an orange and trying to press the peel flat. The surface stretches, DOT, because a sphere cannot become a perfect flat sheet. This is exactly the challenge, DOT, behind every world map ever created. Cartographers must choose what information to preserve. Some maps protect direction, some protect shape. But no flat map can preserve everything. The most common world maps, DOT, stretch areas near the poles. That is why countries near the Arctic, DOT, appear much larger than they really are. And it is also why northern flight routes, DOT, look strangely long. But place that same flight path on a globe, and the mystery disappears. The airplane is not making a detour. It is following the natural curve of the Earth. This is the first illusion, DOT, created by flat maps. They look accurate, but they do not always show true distance. So, if the map is misleading our eyes, what path are airplanes? The answer comes from DOT, one of the most important ideas in geography. The shortest path between 2 points on a sphere is not a normal straight line. It follows a special curve called a great circle route. On a flat map, DOT, this route appears curved. But on Earth, DOT, it is the shortest possible path. Think of a string stretched tightly between 2 points on a globe. The string naturally follows DOT, the great circle path. That same principle guides DOT many long-distance flights today. Airlines are not choosing routes based on how they look on a screen. They are using mathematics, DOT, navigation systems, and computers. Every long flight is carefully calculated, DOT, to reduce distance and fuel use. Even a small improvement, DOT, can save thousands of dollars. For airlines operating hundreds of flights, DOT, small savings become a few enormous. Kilometers saved on every trip, DOT, can mean tons of fuel saved every year. So the goal is not to create the straightest looking line on a map. The goal is to find the most efficient path in the real world. But there is still one mystery left. Why does a perfectly logical route on a globe, DOT, look so strange on a map? The answer takes us deeper, DOT, into how humans represent the planet. And it reveals why, DOT, the map you trust may be hiding reality, DOT, to understand why flight paths look strange. we need to understand one simple fact. Earth is not a flat surface. It is a curved world. But our brains are trained to see the world around us as flat. When you stand on the ground, the curve of Earth is almost invisible. The horizon looks perfectly straight, so our minds naturally assume. But from higher altitudes, the reality becomes easier to see. The horizon begins to curve, revealing the true shape of our planet. This small curve changes everything, about how distances work. On a flat surface, a straight line is always the shortest route. But on a sphere, the rules are completely different. The shortest path must follow the shape of the planet itself. That is why a flight route can look curved on your phone, while the airplane is actually taking the most direct path possible. The pilots are not looking at a simple flat map, and guessing. Modern navigation systems calculate routes using Earth's actual geometry. Every flight is based on complex calculations made before and during the journey. Is only one part of the equation. A route that is mathematically shortest is not always the fastest in reality, because the sky itself has invisible forces. One of the biggest factors is something called the jet stream. High above Earth, powerful rivers of air are constantly moving. These fast-moving winds can reach hundreds of kilometers per hour. When an airplane catches a strong tailwind, it can travel faster, without using extra fuel. But flying against these winds, can slow a plane down dramatically. That is why airlines sometimes choose a route that looks longer, because the fastest route is not always the shortest route. A small detour with favorable winds can save time and fuel. This is why the same flight can take different amounts of time, depending on whether it is flying eastbound or westbound. The atmosphere itself becomes part of the flight plan. Airlines constantly monitor weather patterns and wind conditions. A route that changes by only a few kilometers can create major savings. Every decision is a balance between distance, speed, and efficiency. So when you see an airplane taking an unexpected path, it may not be avoiding something. It may actually be using the invisible highways of the atmosphere. But even with perfect calculations, airlines cannot simply fly anywhere. There are other hidden factors that shape every flight route, and some of them have nothing to do with distance at all. The next piece of the puzzle is something passengers rarely see. A complex, invisible map of restrictions and safety zones. Because the sky above Earth is not completely free to travel through. Every route is carefully planned around rules, risks, and real-world limits. And that is why a flight path is never just a simple line between two cities. Behind every curve on a map is a hidden story of mathematics, weather, technology, and human decisions. When you look at a flight path on a map, dot, you are only seeing a simplified picture. Behind that line is a huge system dot making thousands of calculations. The shortest distance, the strongest winds. Fuel efficiency, dot, and safety requirements all matter. This is why a flight route dot can change from one day to another. The airplane may follow a different path even between the same two cities, because the sky is constantly changing. Wind patterns move, weather systems develop, and every flight must adapt to the conditions of that exact moment. But there is another reason many flights travel farther north. The Arctic region, dot, which looks extreme on a map, can actually be the perfect shortcut between distant continents. For example, a flight between East Asia and North America may save hundreds of kilometers by crossing closer to the Arctic. On a flat map, dot, this route looks like a giant curve. But on a globe, dot, it becomes a natural and efficient path. This is the Great Circle route in action. The same idea that confused U is actually what makes the flight shorter. But distance is not the only thing airlines have to consider. Sometimes, the best route is not the shortest route. It is the route that saves the most fuel and time. Fuel is one of the largest costs in commercial aviation. A long-distance airplane can burn tens of thousands of liters of fuel. So even a small improvement can create huge savings. Airlines use advanced computers to find the most efficient route. They calculate altitude, speed, weather, and wind conditions. The final route is a balance between many different factors. A slightly longer path with strong tailwinds may actually arrive earlier and burn less fuel. This is why flight planning is a massive optimization problem. Every aircraft is searching for the smartest path through the atmosphere. But fuel and weather are only part of the story. There is another factor that always comes first. Safety. The sky may look empty, but it is actually carefully controlled. Aircraft cannot simply fly wherever they want. Some areas are restricted for military or security reasons. Others may be avoided because of conflict, dangerous conditions, or temporary restrictions. Severe storms can also force airplanes to change their planned route. Modern aircraft use weather radar to avoid dangerous areas. A route that looks inefficient may actually be the safest choice. Every turn in the sky has a reason behind it. Because in aviation, safety always comes first. 140 hours, 15 minutes, and 0 seconds. It is the result of thousands of decisions made by technology and people. A flight route is not just a line. Fuel, connecting two cities all work together. Every choice is designed to create the safest and most efficient journey. This is why airplanes sometimes appear to take strange paths. They are not lost. They are solving a complicated problem. A problem involving mathematics, physics, geography, and real-world conditions. The route you see on a screen is only the final result. You don't see the calculations happening behind it. You don't see the wind forecasts, the restricted zones, or the thousands of safety checks completed before takeoff. What looks like a strange curve is often the smartest solution. The biggest misunderstanding comes from looking at a three-dimensional world through a two-dimensional picture. A flat map is useful, but it can never perfectly represent Earth. It changes the way we see distance, direction, and movement. That is why a route that looks longer may actually be much shorter. The airplane was never flying in a strange way. We were simply looking at the wrong perspective. Change the perspective, and the mystery disappears. A flight path that looked impossible suddenly becomes completely logical. This lesson goes beyond airplanes. It shows how easily our perception can be changed by the way information is presented. Sometimes, the problem is not reality itself. The problem is how we choose to view it. A map is only a model of the world. And every model has limitations. The more we understand those limitations, the better we understand the world around us. So the next time you see a flight route bending across a map, remember that it is not wasting distance. It is following the true shape of our planet. A route that looks unusual may actually be the most efficient one. Because on a round Earth, the shortest path is rarely a straight line on a flat map. It is a path that follows the curve of the planet itself. From space, these flight routes make perfect sense. Every curve tells a story, about science and optimization. What once looked like a mistake, is actually a masterpiece of engineering. A combination of mathematics, technology, and human knowledge. So, the next time you look at a map, and see an airplane taking a strange route, you will know the truth. The airplane is not taking a detour. It is taking the smartest path across a curved world. And perhaps the most fascinating discovery, Dot, is not how airplanes fly, but how easily our own eyes can misunderstand reality. Sometimes changing the way we look, Dot, is enough to change what we understand.